Hi class, today I'm going to talk to you a little bit about our very first hands-on project in here. This is going to be a pretty major project, one that I think you'll have fun with. I want you to take your time, don't try and rush through it. I don't want you to get frustrated. Probably the first step in this bridge project is going to be the design process. You have to think things through. You have to be very deliberate, and you need to first of all think about the problem. The problem is that we have to create a bridge, and we're going to make this bridge to a small scale size. We're going to make it approximately 12 to 13 inches. So it's going to require you at this point, after you've thought through the problem, is you're going to have to then decide what you're going to do, which would be the design statement. You're going to be designing a bridge that will hold weight. We're actually going to suspend a bucket under the bridge with a hook bolt and a 5-gallon bucket, and we will be filling the bucket with sand. So we want to see who can create. We're going to make a competition about it, and we're going to see whose bridge can hold the most weight, but not only hold the most weight, but see whose bridge is the most efficient, which means that a bridge that holds less weight could actually, in this competition, beat a bridge that holds more weight if your bridge weighs less. So it's going to be a math formula that we figure to see whose bridge is the most efficient. We're going to see the actual weight of the bridge, and we are going to divide the weight of the bridge into the amount of weight that it held until it fails, and that will give us a efficiency percentage. So it's going to be fun. We're going to make a competition out of it. In the design process, we have constraints. Constraints would be the limits of the size of the bridge. So our bridge is going to be in between 12 and 13 inches long. The road bed, or the distance across the bridge from one side to the other, is going to be a minimum of 2 3/8 inches. That allows us to get the washer in there and the bolt through to suspend the bucket. It needs to pretty much be 2 3/8 inches wide minimum to do what we need to do in order to test it. Your deliverables on this are going to be what you have when you're finished. Well, we're going to have drawn out plans of the bridge. We're going to have a finished drawing of the bridge. We're going to have some sketches, then we're going to have a finished drawing, and then we're also going to have the prototype, or the testable prototype, which will be the bridge that we'll have we use for the competition. The next step would be to draw those 3 design sketches. We're going to ideate. We're going to think through the problem. And the design sketches should be neat, but at this point on a sketch, you don't necessarily have to use a ruler or be as precise, but you still need to be neat. You need to be able to show your ideas so that somebody else looking at your idea understands it. You don't want it to be sloppy. You want it to be neat. The step after this would be, I'd like for you guys at this point to make 3 design sketches, 3 ideas. You can do this by hand, by drawing it, or you could do it digitally. Now, in the past, we've used a program called West Point Bridge Designer, but it's only available on a PC, and we have iPads. So if you can come up with a good digital alternative to hand drawing, feel free to do that. I'm just not sure. I haven't done enough research with the iPad to see what's out there. But if you find something, share that with me, and I'd be glad to let you use it. Once we've come up with 3 sketches, then we need to take the design that we like the most, the sketch design that we like the most, and you're going to have to actually draw this to nice scale dimensions. You want to make sure that your design is symmetrical. And what I mean by symmetrical is one side of your bridge needs to be exactly the same as the other side of the bridge. Also, you want to keep your design fairly simple, because you'll see in the rules, I'm going to give you a rubric, there is a maximum weight that your bridge can be. So you don't want to get too carried away with using too many materials. You want to keep it fairly simple. You want to use geometric triangular shapes to support your bridge. Triangles and X's would be your strongest structural supports. Your bridge should have superstructure, which is support and bracing above the roadbed of the bridge. It can have substructure as well. It could have some bracing underneath the roadbed of the bridge as well. Preparing the work surface. Now, once we have our finished drawing, we have it drawn to the exact size in between 12 to 13 inches, 2.5 inches in depth. We are going to tape down our design of the side pattern of our bridge to a piece of foam board that I'm including in the kit. You are going to tape that down directly to the foam board. And then in the kit I also include wax paper. Wax paper will go over the top of your drawing. That's going to protect your drawing from the glue that we're going to use. It's also going to prevent your bridge components from sticking to the paper. Wax paper has a slick, waxy surface, so it won't stick as much. You may have to peel it a little bit, but it's going to come off of that a lot easier than if you glued it directly to your plan. Plus, you're going to reuse that drawing, that plan that you made for the other side of your bridge. Your bridge is going to have two sides, just like a regular bridge would have. So you're going to need to reuse your drawing. Unless you plan on drawing it twice, I would suggest you use the wax paper and just have to draw it once. Next, you'll start placing and gluing the outside bridge framework. So you'll want to precisely cut straight pieces, and I would start systematically just building the outside edges of your bridge. Your kit has sewing pins in it. The wood that we're using is fairly soft, so you can pin through the wood material. On the ends of every stick that are joining together, you'll want to put just a slight drop of glue. You don't want to get carried away with the glue. Remember that our weight is going to be, there's going to be a maximum weight, and this is listed on your rubric, of 45 grams or a little over 1.5 ounces. Closer to 2 ounces, actually. So we want to keep the weight down as much as possible. So once you've built the framework of your bridge, then you can start filling in the structure, like the visual here. You'll start making the braces and supports, the beams, if you will, of the structure, of the superstructure above the roadbed. Once you've done that, you're going to repeat that step and make the other side. So this is kind of what one side might look like when it's completed, one side of your bridge. And then you would have to peel that off, repeat the process, make another side of your bridge. Once that's done, then you're going to create the roadbed. And the roadbed on this bridge, I don't want it to be just sandwiched together solid material. We are actually going to, and this will make it easier as well to run the bolt through the middle, because we will have some little spaces where we can easily drill up through the middle to run that bolt through. We are going to make it to where you'll have a solid length stick, and then you'll have some shorter pieces in between. So the roadbed, as you can see in this visual, is not actually a solid roadbed. You're going to have spaces in between. You'll have one long stick, and then you'll have smaller, shorter sticks between that, and then you'll go with a solid stick again, and you're going to alternate solid and then spacers, solid and then spacers, until you get a roadbed that is a minimum of 2 3/8 inches wide. 2 3/8 inches is about the minimum we can do to test it. So you can have it wider than that, but we want to have a minimum width of 2 3/8 inches wide. Once you have created your sides, you've created your roadbed, then we can assemble all of the bridge parts together using glue and pins to hold it together until it dries. You want to leave this for about 24 hours, just like, let me go back. When you make the sides of your bridge, also make sure that you wait 24 hours to allow the glue to completely dry. If you try and peel it off or lift it or move it before the 24 hours, it's going to be weak and it may break on you and cause some frustration. So let it sit and just dry. Don't be impatient. Let it do what it's supposed to do. And the final step of this is going to be you're going to have a bridge with integrity. It's going to be strong, hopefully, and then we're going to, for the final step, is we're going to test this. We're going to put a hook bolt through it. We're going to hang it from a bucket and suspend it from a bucket, and we will be filling it with sand. Hopefully we'll be back in person by the time we get ready to do this. If not, I'll have to figure out another way, possibly to collect those from you and show you online, each one being tested for each class. Either way will work out great, and you'll have fun seeing it tested. I like to call this project Sperreng Bridges Falling Down. And that's the end of my presentation. Hope you enjoy it. You can go back and watch it again if you need to see some of the steps along the way, and we'll be working through this in class as well. Thank you.